circle ABC has a center at O. DE is tangent to the circle at C. Angle BAC is equal to 37 degrees and angle ADC is equal to 65 degrees. And so here we have this diagram and our goal is to find angle ABC. Now when they say angle ABC, what they are referring to is they're referring to this particular triangle, angle A, so angle AB, right? Angle ABC. So they're referring to this particular triangle, right? So angle ABC, they're referring to this particular triangle. And the angle that they're referring to is this angle right there, B, all right? The one in the middle, all right? So they want us to figure out what is the measure or what is the size of this angle, angle B, all right? And so that's what we have to figure out. What is the size or what is the measure of angle B, this angle right there. And so we're going to use this theorem. The theorem says that the angle in a semicircle is 90 degrees. And so if you know that, if you look at this diagram, we have this diameter AB, and the diameter AB separates the circle into two halves. So this right here is a semicircle, and this at the bottom is a semicircle. And the angle right here, right? The angle in a semicircle is 90 degrees. And so we have the same thing here. We have AC is the diameter, right? Because we have this point as O. So this chord that passes through the center of the circle and touches both ends of the circumference is definitely the diameter, AC. And notice that this diameter cuts the circle into two halves. So this is a semicircle right there. And this right is also a semicircle, all right? And we have an angle right here, which is in a semicircle, and this angle is B. And according to this theorem, this angle is 90 degrees. And so that means that angle ABC is equal to 90 degrees. All right, next. And the reason is because angles in a semicircle, the reason is because the angle in a semicircle is 90 degrees. All right, next, we have to determine, so we already know that this is 90. Now we have to determine angle BCE. Now when they say BCE, they're referring to, notice that we have, this is B, all right? This is C, and this is E, all right? So when they say BCE, they're actually referring to, let me highlight it. So when they say BCE, let me use this color. So they're referring to B, C, and E. So the angle that they're referring to is actually angle C, the one in the middle. And so what we have here is we have to figure out, okay, what is the measure or what is the size of this angle right there? This angle right there. Let me put an asterisk here. So you need to figure out what is the size of that angle, all right? Now, in order to do that, we are going to use this theorem, the alternate segment theorem. And the alternate segment theorem says that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. And so what that means is if you have a tangent, so this is the tangent, right? This is the tangent, this black line. If you have the tangent line and if you have a chord, so this green line is a chord, right? And the angle formed between the chord and the tangent is theta, all right? And so what they're saying is this angle theta is equal to this angle right here. And the reason why they are equal is because notice that this angle theta, the same angle right here, this angle lies in another segment, and this angle is subtended, right? This angle right here, the legs of this angle, right? The legs of this angle rests on this chord, all right? So the legs of this angle rests on this chord, and that's what it means when it says that the angle is subtended by the chord, because if we look at this angle theta, the legs of it rests on the same chord AC, all right? And that's the exact chord that forms an angle with the tangent line. And so they're saying that these two angles are going to be equal, all right? And so we have the same thing here. We have this angle theta, or we have this angle, which is 37 degrees. and we also have this angle, right? So first we have the tangent line, DE, that's a tangent line. And the tangent line forms an angle with this chord, CB, all right? And so this chord, CB, and this tangent, they form an angle, and this is the angle right here, right? Now, interestingly enough, the same, the same, the same chord, right? The same chord right here that which would be that we use to form an angle with the tangent, the same chord is the same chord that is used. This is the same chord upon which the legs of this angle, right? This angle that measures 37 degrees rest upon or lies upon, all right? And so this angle right here, right? This angle is subtended by this chord, which means that the legs of this angle rests on this yellow line, this chord. And so what that means is that this angle right here, based on the alternate segment theorem, this angle that measures 37 degrees and this angle right here, they are equal, all right? They are equal. And so that means that angle BCE is equal to 37 degrees. And the reason is because of the alternate segment theorem. Next, we have, so we know that this is 90, we know that this is 37. Next, we have angle DAC. Now, DAC, so when they say DAC, they're referring to this triangle. So we have DA, all right, DA and C, all right, DAC, all right. So they're actually referring to this triangle, all right? But the angle that we are focusing on is this angle, angle A, all right? And so let me put an asterisk for that angle. So we will be actually trying to figure out is what is the measure of this angle right here, all right? This same angle, angle A, all right? And so that's what we have to figure out. That's our goal. Now, what do we do know? Well, we do know that this is 65 degrees, but what is angle C, right? Well, according to this theorem, it states that the angle between the tangent and the radius is 90 degrees. Now, this right here is the tangent line, all right? And this side, this line CO, right? This line CO is the radius, all right? So we have a radius and we have the tangent, and the line that's formed between the radius and the tangent is 90 degrees. And so that means that this angle right here, this angle right here is 90 degrees, right? So this is 90 degrees, okay? And so that is useful because if we know that this is 90 degrees and this is 65, and we just need to figure what this angle is, then we can use the idea or the rule that angles in a triangle add up to 180 degrees, which means that 65, 90, and A is supposed to add up to 180 degrees. So if we're trying to figure what is angle A, all we have to do is add 65 and 90, add them together, and then take that sum and subtract it from 180, and then we'll get angle A. And so that's what we're gonna do. So we take 180 and we subtract it with 65 plus 90. And what we have is we have 180 minus 155 because 65 plus 90 is 155. So we have 180 minus 155, and 180 minus 155 is going to be equal to 25 degrees. And so that means that angle DAC is equal to 25 degrees. And that's the answer to this question.